Okay, so today we are going to practice analyzing satellite images again. The instructions say students will analyze satellite images from around the world to identify land and erosional features to predict how these features may continue to be reshaped by erosion. So we're focusing on what erosion does to land. Erosion is the removal or movement of land. So whether that be grass and trees and vegetation and soil and rocks, the movement of any kind of land, any part of land is erosion. Okay, included in this resource is a blank table for students to use as they explore these satellite images. You are going to make observations on each of these slides and propose how geological processes have altered the surface. So we're going to look at Las Vegas, Nevada, and the urbanization. And what that means is how Las Vegas has grown as a city and what that has done to the land around it. We're going to look at South Africa, a before and after, how it's changed from 2014 to 2017. We're going to look at a glacier area, and we're going to look at the Florida Keys Islands. You do not need to click any links. You just need to read each of these slides. And this is the graphic organizer. And there's text boxes for you to type the information that you observe, and you want to fill in these boxes. So our first box is going to be Las Vegas, Nevada. We're going to observe then and now. Okay, and it says in 1972, what do you notice? However, now what do you see? What geological process is evident in this scenario? So those are the questions that we're going to be answering for each one of these 4 locations. So our first step is to look at the pictures and read the text that goes along with it. Okay, so in this first image, we can see that Las Vegas is really tiny. We do have, it looks like some mountains right here, a lot of desert. There's not a lot of green or vegetation, and the green we see is representing the city. So I don't see any kind of vegetation or plant life. And then I see a really, really big lake. And then when I move on to the second image, the city is grown like crazy. The amount of green and purple I see for this city is dramatically changed. And it's come into the mountain area at the bottom part of this image. The lake to me looks darker, but I don't really think that the size has changed too much or the shape has changed too much. And this river right here also looks darker to me. So that might be an indicator of depth. Maybe the depth of this area increased, or maybe the pollution has increased into this lake. I do know that Las Vegas uses this as, I believe this is a reservoir. This is where they get their water from. I'm not 100% sure that's accurate, but I've got a pretty good idea. So Las Vegas relies really heavily on this lake for electricity from Hoover Dam and as a clean water source. So if it is becoming pollution due to runoff from the city, that's going to limit their healthy resources for this city of over 2 million people. And as you can see, there's not any vegetation around either. So they're pretty tight on resources. The final image, the city is almost doubled in size, it looks like. And it merges right into that mountain range. And then something that I notice about the lake is that it looks smaller. It looks like it's decreased inside. We have like somewhat of like a little peninsula right here. And so that's concerning considering they use this area to power their electricity and as a water source. On this document, we're going to restate our observations. So what we discussed as a class is in the then observations in the 1972 image, we noticed a little bit of green, which represents the people and the city. And we noticed mountains, a lake, and a river. In our now observations, we noticed the city grew a lot. It almost doubled or tripled in size. And we noticed the lake and dam and river area looked smaller and darker. We said that this is probably because of pollution due to city runoff from the city. And we said that maybe the lake looks smaller because more people means more water use. So the water from the dam is being used faster than it can be replaced. So that would tell me their groundwater supply would be depleting, would be decreasing. And the geological process that was evident to us was a little erosion around the lake because of the decreasing water levels. Our next satellite image is going to be Pine Island Glacier. Again, we're going to start off by observing our images and reading the text to support, and then we will go fill in our table. Again, when we analyze this image, the important information the text gave us is in this September 21st image, we have a Paulina, I think I'm pronouncing that right, and that's an area of warm water. And then on this glacier, we have a small rift. And then when you look at the January 2nd image, you can see that that area broke away, and when it hit the other side, it shattered very easily into smaller pieces. And we're discussing why we think that occurred. One student said that the warmer water made that small sheet of ice very fragile, so that when it hit the other side of the ice, it was weakened and it shattered very easily. And I think that's a really plausible idea. I don't think that's why it broke away. I think that maybe a small earthquake or something caused that rift, because the warm water in the first image is not really close to that rift per se. But after it broke away, I think the warm water might have interacted with that piece of ice and caused it to weaken, so that when it did make contact with the other side, it shattered very easily. So I think those are really good analysis. Okay, to summarize what we typed in our graphic organizer, we said that in September we can see a big block of ice and that there's a small rift, but we observed that it is further away from the warm water area. And then the now observations, we see in January a chunk of ice broke off and it shattered into a lot of pieces. We're saying that this was probably caused by, it says, the affects Earth's crustal features. This is affecting it, or how Earth's crustal features affected it. We said there was some type of plate movement that caused the rift, and that the warm water area weakened that chunk that broke off, causing it to shatter into a bunch of pieces. And I actually think that they'll probably continue to melt away and then get smaller and break into smaller pieces. The next land area we're going to discuss is South Africa. We're going to read the text and analyze these images as a class. So our analysis of the text is this area of South Africa. In the first image, this is when their reservoir was at full capacity. But over the course of from 2015 to 2018, their amount of rainfall decreased more than half. It said that in 2017, they only received about 6.2 inches, whereas the normal annual rainfall is 20.3 inches. So they have had a significant drought, which means they have had no rain. And they anticipated running out of water even by mid-April 2018. So when we look at this first image, we see a lot of green, a lot of vegetation. We see smaller bodies of water. Those darker dots, those are probably smaller reservoirs. And then we see the big reservoir. When we look at the after image, the landscape looks a lot darker. I do see a slight decrease in vegetation. The smaller reservoirs don't look like their size has changed too much, but this reservoir, especially in this area, has dried out significantly. I mean, you can see the dried out lake part of that, and this is all that they have left in 2018. And so that's probably another reason why it looks more dry and less vegetation in the second image. So now we're going to fill in our observations on our graphic organizer. So when analyzing these images for our graphic organizer, in the 2014 image, we said that we could see a lot of green, which represents vegetation and plant life. We can see a big full lake, a lot of smaller bodies of water. But when we look at the 2015 image, this is a year later, we see a little less vegetation. The landscape looked darker and drier. And then we said the reservoir was more than halfway dried up. And we said this event will lead to changes in Earth's crustal features by more erosion. That as that reservoir continues to dry up and eventually dries up entirely, that it's going to erode away, which means it will become less deep. Therefore, it won't, when it does finally rain and that drought finally ends, it won't fill up as much as it did in the past. So their reservoir will never be what it was. They'll never be able to have the same capacity to support their communities the way that they were in the past, because the erosion is going to make that lake and that reservoir less deep. It's going to make flatten that surface, and it won't be able to fill up like it did before. Okay, so this is stating that this area of islands, Irma churns up. So Irma, I believe, was a hurricane, and it churns up sediment. So what that means is it stirred it up. It's like stirring up the pot. Hurricane Irma crossed the Florida Keys the morning of September 10th, 2017. It was a Category 4 hurricane. The distinct line south of the Keys where the sediment ends is a steep drop-off. So if you look in this first image, you can see a lighter blue color and you can see a darker ocean color. So that indicates that the depth increases at that darker color. The edge of the continental shelf on which the Keys sits, the darker color indicates deeper water. In the close-up image of March after the hurricane, a pattern emerges near the Marquise Keys. These aren't water waves, but sand ripples. So these like brownish, these light greenish brown colored ripples, that's sand. After the storm, those ripples are obscured by suspended sediment. So the ocean water was still moving, and it was like it was stirring it with the sand. Minor hurricanes enhance biodiversity by clearing the reef of dead organisms, but major hurricanes like Irma can damage marine habitat. The Florida Keys National Marine Sanctuary is still assessing any damage that may have been done. So if we look at both of these images, you can see the reef area, or the higher place of elevation in the ocean around this area. You can see it really well. It's really clear. And after, you can't really see it at all. It all looks the same color. It looks like the hurricane brought a lot of sediment into the marine life of this area, kind of overpowering it. They don't look like the same place. It looks like I just see a bunch of green, and I'm guessing that's dirt. Whereas in the first image, you can see a lot of different shades. So we're going to continue to fill out our graphic organizer, and then you guys just complete the check for understanding, where you look at satellite images and you answer a question to show that you're correctly interpreting and analyzing them.